My name is Hannah and I'm a volunteer with Let's Talk Science at the University of Victoria. Today we're going to be exploring where mathematics show up in nature, and we're going to do some drawing. About 800 years ago there was a man named Leonardo Fibonacci. He was born in Italy, but he traveled widely to study mathematics in Egypt, Syria, Greece, and beyond. At that time, most people in Europe did not use the Arabic number system that we use today, and Fibonacci was one of the first Europeans to write books about mathematics using Arabic numbers. If you recognize Fibonacci's name, it's probably because there's a mathematical phenomenon named after him. This is the start of the Fibonacci sequence. I'm going to give you a moment to see if you can find the pattern. Feel free to pause the video if you want more time to figure it out. A French mathematician named Albert Girard came up with a formula for calculating each term in the Fibonacci sequence. As you might have figured out, each term is the sum of the previous two terms. If we look at the sequence again, we can see this pattern. 1 plus 1 equals 2, 1 plus 2 equals 3, 2 plus 3 equals 5, 3 plus 5 equals 8, and so on. We're going to do the drawing activity next, so you're going to need a few things. In a moment, I will give you a chance to pause the video and go collect them. You will need a sheet of graph or grid paper. If you have a printer, there are lots of templates online that you can print off. You can use graph paper that you already have, or you can buy a pack of graph paper. You will also need about 6 or 8 colored pencils or crayons. I'll let you pause the video now to collect those things. First, place your finger near the middle of the paper. This is where our drawing will start. The first number in the Fibonacci sequence is 1, so the first square we're going to color will have sides that are 1 unit long. Now we're going to rotate our paper a quarter of a turn to the left. The next number in the Fibonacci sequence is another 1, so we're going to choose a new color and draw another square with sides 1 unit long right on top of the first one. And again, we're going to rotate our paper to the left. The next number is 2. We're going to choose a new color and draw a square with sides that are 2 units long, but where we draw it matters. You want one side to be right on top of the 2 squares you've already drawn. And we'll turn the paper again. And now we have 3. The top of your colored shape should be 3 units long, and we're going to line up the 3 by 3 square with the top of that colored section. And let's turn the paper again. Okay, now we have number 5. I'm just going to count along the colored section to make sure we have 5. 1, 2, 3, 4, 5. Perfect. So we're also going to go up 5, because if you remember, squares always have sides of the same length. And across the top 5 as well, and then back down to make a square. We can keep going like this until you reach the edge of the paper. Remember to choose a new color and rotate the paper to the left each time. I'll put the Fibonacci sequence up on the screen so you know how big to make the squares. By the end, you will probably notice a spiral pattern. If you draw an arc through two corners of each square, you can trace the logarithmic spiral that is characteristic of the Fibonacci sequence. One of the reasons the Fibonacci sequence is significant is because the logarithmic spiral we just drew shows up a lot of places in nature. A few examples are snail shells, sunflower seeds, and DNA. Of course, these natural things all existed before anybody even thought of the Fibonacci sequence, and this is just one example of nature's secret patterns. Next time you look at flowers or go for a walk in the forest, take a look and see if you can find this pattern or any others. Thanks for watching. I hope you enjoyed this video and learned a little bit about how mathematical patterns reflect nature.